Yes, so hello friends, this is the video tutorial for today's GFG problem of today, all subsets Xor sum. So let's read through the question first. It says, given an array ARR, return the sum of the Xor of all the elements for every possible subset of the array. Subsets with the same element should be counted multiple times. So basically, here let's say 7 2. So what are all the subsets of this array? The first subset is that empty array, you don't pick anything. The other subset is we only pick 7, we only pick 2, and the last subset is we pick all of them 3. So these are all the subsets, and for all of them subset, calculate the XOR. So XOR of this empty would be just 0, this would be 7, this would be 2, this would be 7 XOR 2, and add all of these XOR, and this would give you the final answer. So here it will be 7 plus 2 plus 7 XOR 2 equals to 40. So hopefully this makes sense. This example makes sense. The next thing to notice on constraint. So constraint is that n, which is ARR dot size, it can be at max 30, and the values in the array can be as large as 10 raised to the power 3. So yeah, so I've noted the constraints down here. So n is around 30. So for whenever we see that n is around 30 or all of, whenever we want to actually deal with subsets, we get to the point of bit mask. What is bit mask basically? So bit mask is that we initialize a mask variable as 0, and then we go to 2 raised to power n. So that's nothing but 2 raised to power n. Let's say n is 3 here. So for 8, what would be our mask? These would be all of our mask: 0, 1, 2, 3, 4, 5, 6, 7. So if mask is basically like if so here, so we have three values, right? Let's say the three values are 2, 5, and 7 in the array. N is 3, so we have three values. Now whenever in a mask a bit is set, it means we are picking that value. If it is unset, we are not picking it. So here this is just empty, this is just the empty subset. This is the subset with 7, this is the subset with 5, this is the subset with 5 comma 7, because we see this bit is set, this bit is set, and this is the subset of 2, this is the subset of 2 comma 7, this is the subset of 2 comma 5, this is subset of picking everything 2 5 7. So using this we can pick all of our subsets. So this would yeah, and then we can go over all the values in the array and see if it is in the mask. So that is that bit is set in the mask. So like if we are checking for, if we are, let's say our mask is 5, and we are checking for the second value, or let's do check for the first, let's do check for 0th and first index. So 0th index will do 5 and 1 1, uh, basically 2 raised to a 0, so that is just 1. So 5 and 1, so this is so 101 001, this is 1. So yeah, this bit is set, we'll pick the first index. So picking it basically is adding it to a XOR, which I've initialized as x equals to 0 here, and then just adding it to our answer variable, right? Finally, after getting the XOR of all the picked elements. Right, this makes sense. But what is the time complexity here? So this would run 2 raised to the power n times, and this loop will run for each time n times. So our time complexity is n into 2 raised to the power n. And this is like a very generalized time complexity for this bit mask solutions. But here the problem is that n is 30. So if n is 30, this becomes 30 into 2 raised to the power 30. And 2 raised to the power 30, if you see, this is around 10 raised to the power 9. So this thing is actually around 3 into 10 is to the power 10. Obviously, this would TLA, because the maximum number of operations you can do is 10 is to the power 8. So if this is the problem, how we can use this, or how we can solve this? See, this is actually not a bit mask question. This is not a bit mask question. This is actually a DP question. Why DP and how DP? We'll get to it. But the thing that you need to note here is, see, if we are at index AI, or an element AI, we have to make two choices here. Either we pick it or we do not pick it, right? So we make two choices. We pick it, we do not pick it, right? And that is same for all the n's values, right? 0, 1, 2, all the n minus 1 values, all of them have two choices. And that is how you get the number of subsets equals to 2 raised to the power n, because for each you are doing two choices. Now, if you pick it, what would be our impact on AI on a total x? Or let's say x is our XOR of the subset. So if we pick it, the new x would become x XOR AI. If we do not pick it, x would remain x. Right. So this is the impact of our I value. Now, can I go and say that rather than just maintaining our I index, I should also maintain our X? X is what? This XOR till now. So XOR till now, this is our I, and the index I will, it's better we can use the index rather than the value. So our state becomes I comma X. Now I comma X, and from I comma X, if we pick it, we are going to I plus 1 comma X XOR AI. If we do not pick it, we are just going to I plus 1 X. Right, so this is our basically transition table. And what is like if we maintain this as dp, so dp ix becomes dp I plus 1 x x. So this is for picking, and dp I plus 1 x or ai. Right, this is our dp relation. Right, x or ai. Right. Now, what we need to see here again, this can go as large as n. This, what about this? This is actually, this can go as large as 2 into AI, or the maximum value of AI. Why? Because see, for any, uh, okay, yeah, see, for any value, let's say you say, I tell you, give me any value. Let's say you say 7. So 7 has 101. Now, what is 2 times 7? So 2 times 7 is 14. So 14 would be 1 yeah, so 8 1 0 8 4 2, right? Yeah, about 8, this is 14. So the important point to note here is, see, if you have 7 as the maximum value, so now let's say this is the maximum value in the array, so all the values would be having either all the values would be less than 7. So can I say that all the maximum bit that can be set in this in the in the whole array, the maximum bit or the leftmost bit is this bit. After this bit, there cannot be any bit that can be set, because see, 7 is the maximum of the array. If 7 has this bit set, then there is no, if any bit has like even this value, this is 8. This is 8. If 8 is in the sub array, how is 7? 8 is in the array, how is 7 the maximum? So yeah, if you know what is the maximum bit, then if you do the XOR operation and you know that okay, this bit will remain set, if you do the XOR operations, what is the best case you can get? The best case or the maximum value that you can get is basically, because see, we are trying to calculate what is the maximum value of this x, maximum of x, right? So that is basically the maximum XOR you will ever get to for the all the subsets, right? Now, for this point, so yeah, what is the best case you can get is that all of the right mass or all of the right zeros become 1, right? So even that, in that case, that it would be something like this: 1, all the ones are zeros, so that is here. So this is nothing but, okay, this is 7, my bad. So this is 7. So this, so in 2 into maximum value, basically the another bit which is after this is set. So that is why the maximum XOR would always be less than this. So 2 into AI basically. So I think I over confused it. Just to make it simple, see the maximum AI. So this is the maximum value in the array. So the maximum value, if let's say this has this left bit set, 2 into maximum would have a bit after it set. And if you do all this, all the best case you can get is that all of these bits are set, but this has another bit set. So that is why this would always be greater than this, right? This would be always be greater than the maximum XOR. The maximum XOR would always be less than 2 into maximum. Hopefully this makes sense. Even if this is like 2 into maximum becomes this, but this has another bit set which is not set here. So that is why, yeah. So now n. So what would be our total number of states? I do not know why I have to keep doing this. So total number of states would be n into 2 into maximum. N is 30, 2 is 2, and maximum is, as we saw here, 10 is to a 3, where it is. Yeah. Constraints, I wrote it down somewhere. Okay, I don't know. Okay, here it is. That AI is 10 is to a 3. So it becomes. 30 into 2 into 10 raised to the power 3, which becomes 66 into 10 raised to the power 4, which is fine. So now we can go to the code. Let me show you how I implemented it. Sure. I basically created two global variables, nums, which is just the array, and n is basically the size of the array. dp is the dp array that I'm going to use for memorization here. So in nums, I stored my array. In n, I stored the size of the array. In dp, as I said, we'll create an n size dp, and the maximum value could be 2 into maximum value. Rather than calculating the maximum value, I just created it into 2e3 because the maximum value of the AI is 10 is to the power 3. So I just created as 2 into 10 is to the power 3. It should be actually like just to be even better or even more sure, you can do this and just call the recur function. In this recur function, base case is that if I is n, so if I is n, or you have made all the choices and the XOR you were able to get is x, so we just returned x. If this is not n, so you have to make two choices. One is that you pick this element, the other is you do not pick this element, and we are just returning the sum of them. So that, and we store it into dpi. So this works. I can submit this and this should work. Sure, thanks for watching. Hopefully you were able to understand something, and bye bye.